Okay, now we're going to calculate the speed of current at any given time at a given location, just like the height of tide at any time problems. Here for the problem, we'll be looking for the speed of the current at Spuyten Duyvil on October 20th, 1830. I just remember seeing this in the current diagram, so I assume that it is a substation that we can use. But we're trying to find it for exactly 1830, what will be the speed of the current right then and there. Step one, as always, is we just need to look this up in the index. And if it's not there, we'll just pick a different one. 128. Here we go. I'm gonna have to scroll down to the S's. Not too far. Go. We actually have two options. We'll just go with the normal one. So Spuyten Duyvil, right here, 3526. So reference number 3526. And now we need to get our correction information, just like before. So we're going to come back up. Substation started at 68, so I'm going to go to 90 and hope that that's close. That was too far, actually. So 3.2, let's come to the next page. Again, 3526, yeah. Spuyten Duyvil, right there. Perfect. Now we just need to get all the information off of that. Awesome. So just put a straight edge down or a piece of paper, whatever you can, just to make sure you don't lose your place, because this is a ton of different numbers. We're gonna get there. Minimum before flood is 211, 208, 152, 224. And we're on the narrows. So first, let's just set up the table. Let's see. On the narrows, min flood, flood, min ebb, ebb. And we'll put the speeds off to the side, so flood and ebb. So we'll come back. There we go. Okay. So 2 hours, 11 minutes and 2 hours, 8 minutes. Both plus. Plus 0211. 0208. I don't know why these happen to all be occurring after, though technically the main stations are usually the entrances to a harbor area or a major, or like a river delta or something. So the tide would come there first, as it's really the entrance into the ocean. So I think that might be why the substations are usually after. They're not always after. So then we've got 211, 208, 157, and 224, plus 157, plus 224. And then we've got our speed ratios of 0.9 for flood and 1.1 for ebb. 0.9, and 1.1. Perfect. Now we got to go to our main station to find the day we're going to be working with. So we're looking for October 20th at 1830. So the main station, remember, is the Narrows. Our main stations begin on 9. Let's try 15. Boston Harbor, still too north. Start scrolling down. Cod. Cape Cod, still. The Race, so we're getting close. We're in the Long Island Sound. Hell Gate, so we're even closer. Gate, okay. The Narrows, here we go. Okay. So we're in the Narrows. We're going to come down to October. March, so one more page. Oh, wait. June, July, August. Does it really lose the... Did we lose the page? Okay, so the book doesn't have the page for October in the Narrows, so we're just going to change this to August 20th. An STCW question would never include a substation or a main station that you can't get information off of. I've never had that happen. They vetted it in advance. Would be nice if they just updated the books. Okay, but we're going to go with August 20th instead. Here we go. It's a Saturday. Okay. So we're looking for 1830, meaning presumably, well, just like normal, all we need is the times that fall on either side of it. So probably 1629 and 1910. But remember, now instead of working with differences of time of 6 hours, we're doing 3 hours. So there's even more of a chance that everything gets shifted out of place and you need to use different points in time. So we're going to take more than just that. Let's start a couple back. So we'll start... Oh, I was reading off the wrong one. We'll start at 1400 and work our way down to 2308. So at 1404, it's a slack water, and it's slack water that immediately precedes a flood. So let's set up the table. What did I say, 1404? Yeah. 1404, it is a speed of 0. Then at 1714, we have a speed of 1.6, and it is a flood current, making this a minimum before a flood. Then at 1954, we have another slack water. And at 2308, we have an ebb current of 1.9. 1.9 ebb. So here are all of our main station values. We're going to do our corrections, and then we're going to have our true time and speeds for, forget what we are for Spite and Dival. Over here we've got the Narrows. Okay. I didn't see that. That's a little bit out of view for you. Okay. So, time number 1, 1404, is a slack water that occurs immediately before a flood current. So we're going to take the minimum before flood value plus 2 hours, 11 minutes. And we're not doing anything with speeds because it's got a speed of 0. So 2 hours, 11 minutes from 1404, we'll get 16:15 at 17:14, we have a flood current. So we're going to use the flood time correction of 2 hours and 8 minutes. So we get 22. So 1922. Yeah, 1922. And we have a speed ratio of times 0.9. So 1.6 times 0.9 gives us 1.44. So we have the speed of 1.44 flood. Then we have a minimum before an ebb, so we'll do plus 157 and times 1.1. So we add an hour 57, 54 plus 57 is 6 and 3, so it's 9 minutes. 21:51. I want to check if that was right. 54 plus 57 minus 60 is 51, so that's plus 3 hours. Plus 3. Yeah, 22:51. 22:51 at 0.0. And then we're going to have our ebb correction of 2 hours, 24 minutes. Oh, I shouldn't have written that because that's the minimum. And then we multiply that by 1.1. So 2 hours, 24 minutes plus 23:08. It's going to get 32. So 0232 at a speed of 1.9 times 1.1. 0.9 times 1.1. 2.09. Ebb. Okay. So here are all the times in that portion of the day. Obviously, we're starting pretty far into the afternoon. We are looking for 1830. So we need the times on either side of it. And as you can see, it wasn't where I was originally expecting it to be. It is back here between 1615 and 1922. So we're going to take those two. So zoom out a bit. We'll write down on the sides here 1615, 0.0, 1922, 1.44 flood. So we already know that our answer is going to be a flood current because this is when the flood current is the strongest, but we're slowly increasing until that point. We're going to need 3 things. Yes, we're going to need the forget exactly what the terms are used, but the duration, just like before. So the duration between the slack and the flood. We're going to need the I think the speed of the max current that we're closest to, and then the time since the last max current. So let me confirm that, because we're going to finally go to the velocity of current at any time page, which is 94. Okay, here we go. So you can see. Oh, we actually only need the 2. Never mind. So I was wrong. The only 2 factors we need are the interval in time between slack and maximum, so the duration of time, just like in the tide problem, and then the interval between slack and desired time. So we don't actually need the speed of the maximum current. The correction factor we get off of the table will just be applied to the speed no matter what that speed is. So we just need the duration, which is the interval between slack to max, and then the time away from our desired time and the slack, so slack to desired. And that can be forward in time or back in time. If the slack comes after the desired, that's just as valid. You just need to remember that so you can work backwards. So the interval between slack and desired, or slack and maximum, is 16:15 to 19:22. So that is 3 hours, 7 minutes. Yeah, 3 hours, 7 minutes. So right here, slack to max is 3 hours, 7 minutes. And then the interval between slack and desired is 16:15 to 18:30. So that is 2 hours, 15 minutes. So 2 hours, 15 minutes. So those are the two numbers we'll be plugging into the table. Now, the first thing you'll notice about the table is that it's doubled up. There's a table A and a table B. The vast majority of substations use, or main stations use table A. And then any substation based off of a certain list of main stations, you want to use table B. They're just slightly different for whatever reason. And I don't care if you remember which goes where. Always check the list at the bottom before you do this to make sure you're not getting anything wrong. So you can see table A is for all places except those listed for table B. Table B is any substation based off of Cape Cod, Hellgate, Chesapeake, Delaware, Canal, and anything referred to them. So that's not us. So we're based off of the narrows, so it's none of these, meaning we use table A. However, again, always read this because you could very easily end up on one that's on this list without remembering. So we're using table A. We're going to come here and you can see you just take the interval between slack and maximum, the interval between slack and desired, you find where they intersect, and the number they give you there is a correction factor you're going to apply to the speed of the maximum current. So our interval between slack and max is 307, and slack and desired is 215. So you look across, see we've got 2 hours, 3 hours, 3 hours 20. So we're closest technically to 3 hours. So we're going to follow this column. And then our time difference is 215, which is closest to 220. So we follow that row until it intersects our column. And you can see, well, that's annoying, 1.0. Okay, wait, actually, no, 1.9. Yeah, 1.9, I missed my spot. Or 0.9. So if the 2 hour 20 row intersects with the 3 hour column at 0.9. So our correction is 0.9. Meaning whatever the speed of the maximum current is, you multiply it by 0.9 and that gives you your speed at your desired time. So our max speed is 1.44 flood. So you just do 1.44 times 0.9. Here's a calculator. 1.44 times 0.9. You get 1.296. Let's just round that to 1.3. 1.3. And it's still a flood because you're going from a slack water to a maximum flood current. So it's always still a flood. It's just slightly slower. So at 1830, at Spuyten Duyvil on October 20th, On August 20th, because we changed that, our true speed of current at 1830 is 1.3 knots flood. And that's how you find the speed of current at any time. You look up the substation on the index, you use it to get to your substation pages, you get all of your corrections, which there are more corrections for currents than there are for tides. You then go to your main station, you find all the information for the surrounding day at your main station, you apply your correction factors, you get your information for your substation, and then from there, the two pieces of information you need is, well, you find the two times that fall on either side of your desired time, and you get the interval between slack and max, or max and slack if it's going the other way. Write that number down. Then you get the interval between slack and desired time. Whether desired comes before or after slack does not matter. You then plug these two numbers into your velocity of current at any time table, remembering to use table A or table B depending on what main station you're based off of. From there, you get your correction factor, which you multiply to the velocity of the max current that you were closest to, and that will give you your true speed at your desired time, 1.3 knots.